Hey, this is class number 3 for Math 117, and we are continuing our discussion of voting methods. And in particular, we're looking at logic and fairness criteria today from section 1.6. So in our daily summary, in this lesson, we're going to look at 4 fairness criteria. These criteria look at who won in an already completed election and decide if the outcome was unfair. So we're looking at if something is unfair, if the outcome is unfair. All right, so in number 1, the material in this section is tough, so be patient with yourself and expect to struggle with the new vocabulary and ideas. Okay, we're going to start by making sure we have a clear understanding of if-then statements. All right, so suppose I want to stick to an exercise regimen and I plan to follow this rule. If the weather is okay, then I will go for a run in the morning. All right, so this is going to be our rule right here. I want to follow this. This is my exercise regimen. I'm going to follow this. Okay. All right, so in number 3, either the weather is okay or it's not. I wake up in the morning, I look outside my window, and I decide, is the weather okay or is it not okay? And then I make another decision. Either I run or I don't run. All right, we're going to look at each of the 4 possibilities below and decide whether or not we broke our rule in each scenario. And remember that our rule, right, is this highlighted statement up here. Okay. All right, so in part A, the weather is okay, I go for a run. Well, remember the rule said what to do if the weather was okay, and the weather is okay. And if the weather was okay, I was going to go for a run, and I did that. So the weather was okay, and I went for a run. I followed my rule. I was true to myself. I was true to my rule. Okay. All right, in part B, the weather's okay again. So I have a rule for what I'm supposed to do if the weather's okay. But this time I don't go for a run. I just don't feel like it. Right, so I didn't follow my rule here. I didn't do what I was supposed to do if the weather was okay. So I wasn't true to myself, which means that I was false. I broke my rule. This was a false statement. Okay. All right, in part C, the weather is not okay. Well, if I go back and look at the rule, I don't have a rule for what to do if the weather's not okay. Right? So I can't break the rule above. I didn't say what I would do if the weather's not okay. It's all right if I get up and it's raining out and I go for a run. That's okay. All right? So even though I don't have a rule for the weather not being okay, it's all right to go for a run here. I can still think of it as being true to myself. Okay. All right, and the last one, the weather's not okay. So remember from above, I don't have a rule for that, right? It doesn't fit my plan from up above. I don't have anything up there that says what to do if the weather's not okay. Right? So it's in a sense false there. Right? But I don't go for a run that day. Again, I'm not breaking any rules because I didn't say what I had to do if the weather wasn't okay. So this is okay to do. This is still being true to myself. It's still satisfying the rule above. Okay. All right, so note, to summarize this, right, let's summarize these last 2 first. We have no rule for what to do if the weather is not okay. So I can't break the rule then. If there's no rule for what to do if the weather is not okay, the above rule can't be broken. Okay. All right, so number 4, to summarize this, the only way an if-then statement is false is if the if part is true and the then part is false. All right, so notice that part B was the only place where that happened. All right, the if part was true. I satisfied the weather being okay. That part was satisfied. But then the then part, I will go for a run in the morning. I didn't satisfy that because I didn't go for a run. So I had a true and then a false piece. So if the if part is true and the then part is false, then I have an if-then statement that is false overall. All right, so let's see if we can apply this to our analysis of elections. Let's go back to that idea of elections. All right, so for number 5, for a completed election to be considered fair, and completed, keep in mind, means that everybody's voted already, all the votes have been tallied, and a winner has been selected. So for completed election to be considered fair, it must meet certain criteria. The first and most basic expectation is the following, and it's called the majority criterion. If candidate X has a majority of the first place votes, then candidate X should be the winner of the election. So notice we have an if part to our statement and a then part. If something happens, then something else should also happen. And candidate X can be any candidate. It could be candidate 1, candidate A, candidate Sue or Joe. It can be any candidate. All right, so once we completed the election, we'll be able to replace X with the name of the winning candidate. And then check to see if that candidate won and had a majority of the first place votes. All right, so let's try that out in number 6. So we're going to analyze the majority criterion by considering the following preference schedule. All right, so notice number of voters up at the top is 7. 4 plus 2 plus 1 gives us 7 voters. All right, and down here we can see that there are candidates A, B, C, and D. All right, in Part A, does any candidate have a majority of first place votes? Well, to have a majority, they have to have more than half of those first place votes. So 1/2 of 7 is 3.5. So we go up to the next integer, which is 4. So we need 4 first place votes to have a majority. Okay, so let's take a look at everybody's first place votes. A has 4. B doesn't have any. C has 3. 2 plus 1 is 3. And D also doesn't have any, so it has 0. So we do have somebody with a majority. Right? We do have a candidate with a majority of the first place votes. So candidate A has a majority. Remember, more than half, majority of the first place votes. We also say that candidate A is a majority candidate. All right, now we're going to take a look at who wins using the board account method. So this is a good review of the BORDA method. So you've got to go through all 4 candidates. We'll start with A. A receives, remember that if there's 4 candidates, we look first through 4th, then first place gets 4 points, and 3 points for second, 2 points for third, and 1 point for last. All right, so candidate A gets 4 times 4, 16 points for this spot in the preference schedule. And then 2 times 1 plus 1 times 1. And these last place finishes earn 1 point each. And so that gives us a total of 19 points. All right, if we go on to candidate B, we'll look at where B is in our preference schedule. B gets 4 times 2, or 8 points for that first column, 2 times 3 in the middle column, and 1 times 2 in the last column. And that gives candidate B a total of 16 points. All right, candidate C, and that candidate's position in the preference schedule, gets 4 times 3, or 12 points for that first column, or those first 4 voters, plus 2 times 4 plus 1 times 4, which is 24 points. And so right away we're seeing that A isn't going to win, but I want to finish this up and show you D as well. Let's finish and find D's points. So D gets 4 points for that last place finish from the 4 voters in the first column, plus 2 times 2 in the second column, and 1 times 3 in the last column, gives candidate D 11 points overall. So we can see here, again, that A didn't win. It was actually C. Candidate C wins. Okay, great news for C, but not such great news for A. And by the way, remember there is a check here. Let's do a quick check to make sure we have all of our points. 19 plus 16 plus 24 plus 11 is 70. And if you think about each individual ballot, each person, each voter assigns 10 points when they turn in their ballot, and we had 7 voters. which gives us a total of 70 points. So it looks like we got everything all there. We got all 70 points assigned. You remember that doesn't necessarily catch some of the smaller mistakes, but it will catch some of the bigger ones. Okay, so back to this fairness criteria. So note that even though A had a majority of the first place votes, which is the if part of the majority criterion, but A didn't win using the Borda method, and that's the then part of the majority criterion. According to the majority criterion, this is not fair. It's unfair. So we say that in this election, the Borda method violates the majority criterion. And this is an important piece of this statement, because if we leave that out and we say the Borda method violates the majority criterion, someone else is going to interpret that as meaning it always happens. And it does not always happen. It's just that in this particular election, it did. All right, so if we look at that majority criterion again from up above, we can rewrite it and say that candidate A, so I'm just summarizing it, had a majority of first place votes, but candidate A did not win the election. Using the Borda method. Okay, so here was our problem. Again, we had a candidate with a majority of the first place votes, but that candidate didn't win the election using the Borda method. All right, so again, in this election, just this one case, the Borda method violates the majority criterion. Okay, another criterion for fairness is called the Condorcet criterion. In the Condorcet criterion, we say that if candidate X, remember X can be any of the candidates in the election, if candidate X is preferred by the voters over each of the other candidates in a head-to-head comparison, then that candidate, candidate X, who's the Condorcet candidate, should be the winner of the election. So again, if you have a candidate that beats everybody in a head-to-head comparison, that candidate should be the winner of the election. If that candidate is not the winner, then something unfair has happened. Okay. All right, so in number 9, we're going to consider the following preference schedule. Okay. And so we've got 5 candidates here. We've got R, H, F, O, and S. And if we add up this top row, we'll find that the total number of voters is 100. There are 100 voters in this preference schedule. Okay. All right, so part A, who wins according to the plurality method? Well, candidate R gets 49 votes. Candidate H has 48. F has 3. O didn't get any. So I'm going to put first place votes next to that. And S also did not receive any first place votes. So R is our winner according to the plurality method. Okay. All right, in part B, is there a candidate who beats every other candidate in a head-to-head comparison? Well, we have 5 candidates. So remember our rule from before. We can do the number of candidates times 1 less than that number, divided by 2, and it will tell us the number of comparisons we have to take a look at. So there are 10 head-to-head comparisons that we need to consider. So we want to look at candidate R versus everybody else. So we've got R versus the other 4 candidates. And then we've got a few more to look at. We want to look at what happens when H goes against the remaining candidates. Remember, we already have H versus R over here, so we don't need to write it again. And then we've got a few more for candidate F that we haven't seen yet. And we have one more for S versus O. So we've got our 10 comparisons right there. Let's see if I can erase this line here. All right. And let's take a look at what happens with each one of these. All right, so this will be a little time consuming. If you want to press pause and give it a try, you can, and then press play when you're ready. I'm going to do 2 as an example, then I'm going to press pause and fill in the rest. Okay, so I'm going to do this first one as an example, just as a review as to what this method is. All right, so how do we determine a head-to-head winner? All right, so if we look at R versus H, so I'm going to go up to our preference schedule and highlight where R and H are. Oops, got the wrong candidate in that last column. There's H. Now we're going to see how many voters preferred R over H. Well, the 49 voters in the first column preferred R because R was ranked higher. But the remaining 48 plus 3, which is 51 voters, ranked H higher. So we're going to assume they would prefer H if it came down to just those 2 candidates. So we're going to see that H would win that head-to-head comparison. All right, so I'm going to do one more. I said I would do 2 as an example. We'll do the next one, R versus F. All right, so let me go in and look at where R and F are. And actually, to make this easier, let's pick a different one. Let's pick the last one here. Let's do S versus O. I'll make it a little easier to highlight where they are in the table. Okay, so there's S versus O. So notice that S is preferred by 48 plus 3 is 51 voters in the last 2 columns. O is preferred by the 49 voters in the first column. So S would win that last head-to-head comparison. All right, so I'm going to go ahead and press pause and fill in the rest of the numbers, and you should try this as well on your own just to make sure you remember this method. Okay, so I've got them all filled in. I've got all of the winners of each head-to-head comparison identified. And what we're looking for is whether or not there's a Condorcet candidate. All right, so let's take a look at these point totals. So R, notice, didn't win any head-to-head comparisons. Let's see, our next candidate, let's look at H. H1, let's highlight that. 1, 2, 3. Let's see. Oh, and there's another one, 4. So H won 4 head-to-head comparisons. So H, if we were doing the pairwise comparison method, they would get 4 points. But here we're just really looking at how many head-to-head comparisons there were. And how many they won. Okay. All right, so we know that H is a Condorcet candidate now. So this tells us H is a Condorcet, or is the Condorcet candidate, because H beat every other candidate in a head-to-head comparison. So we don't need to figure out any of the others. All right. We can certainly see that F won 3, S won 2, and candidate O won 1 of these, but this is the critical piece right here. We have a Condorcet candidate. All right, and that's what this fairness criterion had in it. If you have a Condorcet candidate, they should win the election. All right, so H again is the Condorcet candidate. Let's go back up to our rule. So if we have a candidate that's preferred by the voters over each of the other candidates, which we do in a head-to-head comparison, this is candidate H. Here's the then part. Then that candidate, the Condorcet candidate, should be the winner of the election. And that didn't happen here. R was the winner. R won using the plurality method. So we have a conclusion we can make in part C. We say that in this election, the plurality method, which is the one used to pick the winner, violates, we're going to cross out does not violate, it violates the Condorcet criterion. Again, this is key piece here in this election, because it doesn't always happen that the plurality method violates this criterion. It just happened to happen in this particular preference schedule. So again, we have a Condorcet candidate, that's candidate H, but H was not the winner with the method used. All right, the next fairness criterion, it's our third one. It's a little hard to pronounce. You can think of it as it's the monotonicity criterion or the monotonicity criterion. Okay. In this criterion, if the candidate X is the winner of an election, and then there's a re-election, where the only changes in the ballots are changes involving some voters ranking X higher on their ballot and not changing the order of any other candidates, then candidate X should still be the winner of the election. In other words, you have a sense that if someone's going to win or they won in an election, and then they have to have a revote for some reason, and people decide, hey, I want to support the winner, so they bump that person up on their preference ballots, that should only bring about a better win, right? It shouldn't create a situation where that person then loses, and that would seem unfair. So that's really what this criterion is getting at. If you have someone that won the election and for another reason you have to have a re-election, and people move that candidate higher on their ballots, that person should still win. All right, so just like before, we're going to see a situation where that doesn't happen. All right, so in number 11, we've got 3 cities, Athens, Barcelona, and Calgary, and they're competing to host the Summer Olympic Games. The final choice is made by a vote of the IOC, which is the International Olympic Committee, and the winner is chosen using plurality with elimination. 2 days before the actual election is to be held, an unofficial poll of the members of the IOC is conducted just to see how things stand, and the results are in the table below. All right, so using the plurality with elimination, who is expected to win the election? Well, plurality with elimination, we want to be aware of how many voters there are, and if you look at that top row, you'll find that there are 29 voters. And so half of that, because we need to know what more than half is 14.5. So you go up to the next integer. You need 15 first place votes for a majority. So we need to keep that in mind with plurality with elimination. So in plurality with elimination, we're looking at first place votes. So we want to look at candidate A, candidate B, and candidate C. A, note, has 7 plus 4, giving it 11 first place votes. Right? We've got 2 places in that preference schedule where they're ranked at the top. Candidate B only has 8, and C has 10. Right, so nobody has 15 or more, so we need to go to round 2, which means we're going to eliminate candidate B. Eliminate B because B has the fewest first place votes. Okay. And then in the next round, we're going to see what happens. So we've got candidate A and candidate C to take a look at. Meanwhile, remember that B is eliminated, and so that means that in particular here, this middle second column, C is going to get those 8 voters first place choice. All right, so now here are our first place votes. A has 7 plus 4, which is 11. And C now has those 8 voters that originally voted B as first, plus the 10 that originally put C first, which is 18. And that's a majority. So we say that C wins using this method. Using plurality with elimination, C would be the winner. All right, in part B, the results of the unofficial poll are supposed to be secret. Here are the results of that poll. But the results leaked out. And the delegates in the 4th column decide that they want to be able to say that they helped elect the winner. So they put Calgary first and move Athens to second. So we're going to create a new preference schedule and determine the winner of the election using plurality with elimination. Well, it said the last 4 voters. So the first 7 in that table kept their votes the same. So I'm just copying this column in the table and putting it down here. The next 8 voters, same thing. They didn't change their minds. They left the rankings of their candidates the same. 10 voters in the 3rd column also left all of their votes the same, their rankings the same. But those 4 voters in the last column made a switch. All right? And what they did was they wanted to move C up so that it looked like they were supporting the winner. And they left B in place and they moved A down. So again, here we see that 4 voters switched A and C from above. And that's another way of saying they move C up. Higher up on their preference ballots. Okay. All right, so now we want to see what happens. So we're going to once again use plurality with elimination and look to see who wins this election. Okay, so we'll do round 1 and round 2 again. All right, round 1, I'm going to do that over here on the left. And we don't have anybody with 15 first place votes, so we want to take a look. A has 7, B has 8, and C has 14. So no majority, so we're going to eliminate A. Okay, and we'll move on to the second round. So between B and C, okay, we want to see how many first place votes each of them has. And here's where we've got to be careful. A was eliminated, so B's going to move up to get those 7 first place votes. So they get those 7 from the first column plus 8 from the second column. C has 10 plus 4. So C has 14, B has 15. And now we see that we had kind of had some unintended consequences of that action. We see that B ends up winning. And that just doesn't seem fair. I mean, that's what this criterion says. If you have a winner and then you make changes to improve that winner's chances, they should still win. All right, so in part C, to summarize, Calgary was the winner of the unofficial vote. Then a revote happened, and everyone kept their votes exactly the same except some of the voters who moved Calgary higher on their ballots. So this is the key. They moved them higher. And surprisingly, Calgary didn't win the revote. So in this election, we say that the plurality with elimination, so I'm going to have to abbreviate this a little bit to get it to fit. Plurality with elimination violates the monotonicity criterion. Okay, again, in this election, so just like the other two, it doesn't always happen. It just happens in this one, or it just happens to happen in this one. All right, our last one, our final fairness criterion, involves a candidate dropping out of an election. It's known by a few different names. First one is the Independence of Irrelevant Alternatives criterion, which is shortened to IIA, or also called the dropout criterion. And so this criterion says that if candidate X is the winner of an election, and in a recount, one of the non-winning candidates withdraws or is disqualified, then X should still be the winner of the election. So if that candidate withdraws, that's where that dropout name comes from. Somebody drops out of the election. If a non-winner drops out, the original winner should still win. All right, so here's an example down below to illustrate that. So 13, it's time to elect a mayor in Greenfield. There's a very small turnout at the polls as indicated by this preference schedule. And note that there was only 7 voters that voted, okay, which means that a majority would be 4 first place votes. Half of 7 is 3.5, and I'm going up to the next integer. Okay. All right, so in part A, who's the winner using the plurality method? Well, we have 4 candidates. Candidate A has 3 first place votes. Candidate B has 2 first place votes. C has 2 first place votes. And D has no first place votes. All right, so our winner is A. So we've got that A wins. A has the most first place votes. All right, and B, after the votes were all cast, but before the votes had been counted, the people doing the counts are very slow, a scandal involving candidate B comes to light. Candidate B decides to immediately withdraw from the race. Since the votes have already been cast, the election is officially completed. It wouldn't be fair to the candidates or to the voters to ask people to re-vote. So once B has been crossed off all of the ballots, who is the winner of the election using the plurality method? So let's go up and cross out B. All right, B withdraws or drops out. Let's see what happens. So of the remaining candidates, A is still going to have 3 first place votes. C is going to get these 2 voters' first place votes because we're going to assume that candidate C would be their next best choice since they ranked that candidate second, which means C is going to finish with 4 first place votes. And D, unfortunately, still has no first place votes. All right, so here we're seeing that C wins. And that doesn't seem fair. A should still win. Right? Somebody that wasn't going to win dropped out. A should still win. So we have another example of a violation. So we say in this election, the plurality method, because it's the one we were using, violates, so get rid of the does not violate, the dropout criterion, or the IIA criterion. All right, so before you do today's class activity, take a look at the summary of violations of the fairness criteria on pages 35 and 36 of this packet. So make sure you know that that's there, because it could be very helpful to you when you're doing the next few activities. Okay. And for class activity number 3, just want to give you an example. For each of the scenarios described below, you're going to do 3 things. You're going to determine which of the 4 fairness criteria the scenario relates to, and then determine whether or not the scenario demonstrates a violation of the fairness criteria you named in part 1, and then put those results in a summarizing sentence of this form. So in this scenario, put in your voting method. So that could be plurality, it could be plurality with elimination, it could be BORDA, or it could be pairwise comparisons. And then you want to put in either violates or doesn't violate. Okay. And then put in one of those 4 fairness criterions. Okay. So again, in the first blank, fill in a vote counting method. In the second blank, write in violates or doesn't violate. And in the third blank, write one of your fairness criteria. So here's an example of a sentence that's been filled in. In this scenario, the plurality method, so there's my voting method, second blank, does not violate, and then here's my third blank, the Condorcet criterion. Okay. All right, that's it. If you have any questions, send me an email.